Hi, students. This is a review on sex-linked chromosomes and the challenges that some people might face in terms of their inheritance. So we're looking at what's called a karyotype. This is an image of all of our chromosomes. So remember, every chromosome has a pair. They're what we call homologous pairs, and we can see these bands. These bands represents a series or a gene. So we can see that there's dozens or hundreds of genes on every single chromosome. So if we look at chromosome 3, see all these different bands. Those are genes. Those are the instructions for making proteins. You can see that these chromosomes are all different lengths. So the first couple are the longest chromosomes. They have the most genes on them. Your autosomes are fairly consistent. Men and women produce the same genes more or less in the same frequency and the same amount. There will be some natural variation. So maybe one person might metabolize sugar a little bit better than the other because of the slight differences in the genes associated with breaking down sugar. The real place where there's significant difference, or where that results in significant phenotypic difference, meaning differences in our appearance, comes from our sex chromosomes. And our sex chromosomes are this last pair. We see the X and Y chromosomes. So this karyotype is the genome of a man because it has an X chromosome and a Y chromosome. So when we look at the X and the Y chromosome, we see that there is a significant difference between them. The X chromosome is longer and has more genes associated with it. The average X chromosome has about 900 genes. Sorry, I'm paused. Oh, okay. The X chromosome has about 900 genes on the chromosome, while the Y chromosome has about 40 genes on the chromosome. So women with two X chromosomes have approximately 1,800 genes on their sex chromosomes. Remember, XX is woman, XY is man. There are some variations, but those are very rare, something like 1 in 10,000 people. So the genes associated with the X chromosome are related to the development of the female sex organs, the development of the uterus, the development of the ovaries, the development of breast tissue. All of that is associated with the two pairs of X chromosomes. But there's also genes associated with the immune system. So women having two copies of the X chromosome, they have more genes associated with their immune system than men do. So that story about men being babies when it comes to getting sick, there's some truth to that. Women do have a greater number of genes associated with their immune system, so they do, on average, tend to recover from the same infection quicker than a man of a similar age. And this makes sense. Women with the capacity to get pregnant and the fragility of the developing embryo means that they have been selected for having a greater immune system and ability specifically to fight infections than the average man does, who does not have as many copies of the genes because we have a associated Y chromosome. And the Y chromosome has genes associated with the development of the male anatomy and male features. Among those things would be a region called the sex-determining region Y. That is a series of genes that are responsible for the development of the testes and male anatomy. Now, there are possible mutations that happen, mutations meaning changes and errors to the genetic code in both the X and the Y chromosome. Now, the X chromosome being larger, significantly larger, 20-something times larger than the Y chromosome, means that there's more possibilities for error and mutation in the X chromosome. So that means that when there are mutations in the X chromosome, it is more likely to be detrimental to a boy than it is to a girl, because a boy inherits his X chromosome from mom, meaning he has one set of instructions for the X chromosome, whereas a girl inherits an X chromosome from mom and from dad, meaning that they have two copies of the instructions. And so if one copy of the instructions has a mutation or an error, they still have another copy of the instructions that is error-free, whereas boys do not have that. So we see a significant number of sex-linked disorders that are far more common to be found in men. Among the disorders that we see more commonly, color blindness, hemophilia. Hemophilia is the disorder where an individual struggles to make blood clotting proteins. We also see something called Fragile X syndrome. Fragile X is a development where it's the number one cause of mental retardation. Developmental delays are associated with Fragile X. And this is something that is more commonly found in boys than in girls. I don't know the exact numbers, but I'd want to say 1 in 7,000 boys will have Fragile X syndrome, where 1 in 11,000 or 12,000 girls will have the same disorder. And the reason for that is the extra copy of the unmutated or error-free X chromosome means that a woman is more likely to produce the proteins associated with normal brain development, whereas a boy, if he only has one copy of those instructions, will make the proteins with those errors more frequently than a girl will. So color blindness is one of those other disorders that is more frequently seen in boys. One kind of informal test that someone can take to see whether or not they have color blindness is how clearly they can see the images that are within these circles. So because there's the difference in the color spectrum, people with severe color blindness will struggle to see these, and on average, boys will struggle to see this more frequently than girls. So one area of genetic disorders is the result of mutations or errors on the X chromosome, which men are more likely to inherit and express. The other set of errors would come from inbreeding, which we talked a little bit about. Inbreeding would be the case where an individual has children with someone closely related to them. Now, if you think about this, if someone has a particular set of mutations or errors in their genetic code, and they have children with someone related to them, that person has a higher probability of having those same errors or similar errors than someone who's just not related to them. And we saw historically the Habsburg family, the royal family of Austria, I believe it's like from 1500 to 1900. We have these oil paintings of them, and we can see these common traits over centuries. And among those things would be this protruding jaw and nose. But there were other features that are associated with this. Generally speaking, when we have genetic disorders, we see diminished physical and mental capability. We also see diminished fertility and shortened lifespans. I believe the last member of the Habsburg family lived to be about 30 years old and was severely mentally disabled, because this is a result of literally close family members inbreeding for centuries. So don't marry your first cousin.